we are going to take a look at vapor pressure and how vapor pressure relates to a vapor pressure diagram. Now, if you are taking Regents chemistry, this is known as table H. Otherwise, you might have a similar vapor pressure diagram that you need to be able to work with. All right, first thing is we see that we have vapor pressure on our y-axis and we have temperature, our x. Vapor pressure is in kilopascals and temperature is in Celsius. Notice the boxes on the y-axis, it's 10 kPa for every box, and for temperature, it's going to be 5 degrees for every degree Celsius for every box. All right, there are 4 liquids here that New York State put on this graph, and how do we get the vapor pressure to begin with? Well, when you have a liquid in a container, the molecules at the surface are going to get enough energy to go into the air. You're not going to have a pressure until you have a lid on that container. Now notice, you've got vapor pressure, and you have temperature. There is nothing here regarding volume. As long as you have some liquid in that container and that container is closed, it is going to exert a pressure on the sides and the top of that container. With these 4 liquids, the curves, notice they don't cross. Water, of course, is the one that we're going to know most, dealing with the weakest forces of attraction between molecules of propanol, better known as acetone, and the strongest forces of attraction here when it comes to ethanoic acid. Well, why would I say that? For example, let's say we're at 75 degrees, and the 75 degree line, if I go ahead and I cross the 4 curves, notice that in the respective containers, they're at different pressures. No 2 are equal. Lowest pressure is going to be ethanoic acid. Why? Because the forces of attraction between them are the strongest, and of course, the highest pressure is going to be for my propanone molecules because they have the weakest forces of attraction between them. This dotted line, 101.3 kilopascals, that is our standard pressure. Wherever the line crosses, normal boiling point for that liquid. Water, you should memorize this anyway if you haven't already, boils at 100 degrees. If you're asked about the normal boiling point for propanone, ethanol, or ethanoic acid, this is where you would look. You just go across and, of course, go down. So in other words, for propanone, that would be 55 degrees. Another question you could be asked, what is the temperature at which ethanol will boil if it has a vapor pressure of 150? Well, you go to 150, of course you go over, you find ethanol, and then you would go down and read it off of the graph. We are going to go over 3 Regents Chem questions, and let's see if you understand the vapor pressure diagram. From the January 2020 Regents exam, question 80 here, determine the vapor pressure of water at 69 degrees Celsius. Notice, does not tell you to go to reference table H. You're going to have to know that on your own. Let's go. We want to go to 69 degrees. Here is my 70 line, so I'm going to go up around 70. It's easier to see and see where it crosses water, and then I'm going to go over, and boxes go up by 10, so 10, 20. It looks to be 30 kPa, or right around there. Typically, the answer key for the teachers will give us a range for the answer, but I would say you're safe with 30 kPa. From the August 2019 Regents exam, question 58 is telling you to go to table H, determine the vapor pressure of water at its final temperature. Well, the final temperature I have to find from the reading passage, and it went from 20 to 50 degrees Celsius. We're looking for the vapor pressure at 50. I need to find my water line, and it seems to cross just above the first box here on the y-axis, so a little higher than 10. I'm going to go with 12 kPa. One more question to go over. All right, for this last question, you have 4 closed containers, and you're asked which will have the highest vapor pressure. You'll notice there are different levels of the water, and you're also given different temperatures. It is right here. It's going to be the 100 milliliters in the container Y, because of the temperature. Remember I said that with the vapor pressure diagram, it's vapor pressure versus temperature. There was no indication as far as volume. As long as you have some liquid in the container and that container is closed, you're going to end up with a vapor pressure at that temperature. That's it. Keep working hard. Good luck.